Today we are going to take notes over piecewise functions, and I'm just going to give you kind of the introduction of it. Piecewise functions, their graphs look a little different. It'll look like one graph going, and then all of a sudden at some point it'll change its path and do something totally different. When you look at the equation for a piecewise function, it also looks like two equations kind of stuck together in one whole function. Today, you're not going to see an actual piecewise function, but I'm just going to kind of introduce you to the idea of what a piecewise function does. As you can see in this example, I have two different equations, one here and one here, and they both have something that happens at 3. This first equation occurs when x is less than 3, and this equation occurs when x is greater than or equal to 3. Since this is just strictly less than 3, I'm going to have an open point at 3. Likewise, just like with the inequalities, since this is greater than or equal to 3, this is going to be a closed point. Now with here, what I want to do is I want to mark this on my graph. So I am going to go where x equals 3, remember that vertical line, and I am going to put a dotted line there. This is where my piecewise function is going to change directions, or where it just changes paths. So from the left up until that dotted line, I'm going to be following the equation 1/3 x minus 1. So I'm going to write that above here so that I know that. 1/3 x minus 1. That's what's going to happen on the left side of my graph. On the right side of my graph, where x is greater than or equal to 3, I'm going to follow negative 2x plus 5. Now the best way to do this is I'm going to take 3, the point that I know, or the place on the graph where my graph is going to end, and then where my new equation is going to start. I'm going to evaluate my equation at 3. So I'm going to plug 3 into the equation. 1/3 times 3 is 1, minus 1 is 0. So I know that my open point is going to be at the point 3, 0. So I'm going to go to 3, 0, put an open point there. And then from here, since I have a point to get the rest of my points, I just need to move my slope. Since I just need to go to the left, I'm going to kind of do everything backwards. So now I'm going to go down 1 and to the left 3. The only reason I'm moving to the left is because we're working backwards and I have to fill in the left side of my graph. So this is what the first half of my piecewise function does up until 3. Now I need to do the same thing but for my second equation. So I'm going to evaluate this equation at 3 as well to see where this graph starts. So negative 2 times 3 is negative 6, plus 5 is negative 1. So I'm going to have my closed point at the point 3, negative 1. So I'm going to come over here just below my other point and put my closed dot there. From here again, we're just going to move our slope, negative 2. So that means I go down 2 and to the right 1. Down 2 and to the right 1. And I'm going to keep doing that until I run off the graph. And there is the last half of my piecewise function. Now when you graph it, try and make your lines straight and have them hit all your dots. Down here at the bottom, it talks about evaluate. So what they want to do is they want to know what's your y value when x is, and then they gave us negative 4, 3, and 7. So for negative 4, I'm going to look on my graph. That's going to be my red graph, and it's not an exact point. Since it's not an exact point, I am going to evaluate it. So 1/3 times 4 minus 1. That's going to be 4/3 minus 1, which is just 1/3. So f of negative 4 is 1/3. f of 3 is really easy because that's already on my graph. I have an open point at 3, 0, and a closed point at 3, negative 1. We remember that the closed point is our included point, so I have to go with that. So at f of 3, the y value is negative 1. And for my last one is 7. I think this one also, 1, 2, 3, 4, 5, 6, 7. Nope, 1, 2, 3, 4, 5, 6, 7. This point down here is where x equals 7, and my y value there is negative 9. So at f of 7, my y value is negative 9. So that's all I wanted you guys to do this first day with piecewise functions. So again, if you look on this last slide, you have your try your own problem. I again gave you 2 different equations. Asked you to graph them at x equals negative 1, and then evaluate given 3 different points. Good luck.